Hello again, grade 9s. This lesson was posted on Tuesday, April 7th at 8 a.m. hopefully, assuming the Google thing did what I asked. So today you are going to be learning how to draw lines of best fit and to look at trends in data, and as well you're going to learn how to interpolate and extrapolate. I know those are big words, but you're going to find they're not that big of a deal. So first of all, just like in class, I would like to start with our first 5-minute question. I have two of them. The first one, if you don't get, you can try the second one. So this is based completely on yesterday, just like we do in class. And what I would like you to do is to read this little sentence here. The number of lights in your house and your hydro bill. And what I want you to do is, for that situation, I want you to determine what's the independent variable and what is the dependent variable. Again, this is based on yesterday's stuff, so I would ask you to pause the video and try it. So please pause now. Okay, hopefully you tried this. If you haven't, please pause and try it first. So we've got the number of lights in your house and your hydro bill. So what you need to figure out is which one depends on the other. Does the number of lights you have depend on your hydro bill, or does your hydro bill depend on the number of lights? Now hopefully you figured out that your hydro bill depends on the number of lights you had. So that means that your hydro bill is your dependent variable, and the number of lights is your independent variable. And if you think about that, hopefully it makes sense. If you have more lights, your bill will go up. So your bill depends on the number of lights. Okay? You're sort of determining which one impacts the other. And the number of lights you is going to impact your hydro bill. Right? Like when your hydro bill comes in the mail, your lights don't just disappear. Right? It's your lights that determine the hydro bill. Or your hydro bill depends on how many lights you have. Okay, so there is a second one of these. I will call it FFM2. And I would really like you to try it again. If you didn't get the first one, or if you didn't even try the first one, please pause and try this. So please pause now. All right, hopefully you gave it a shot. So we've got the number of hot chocolates sold and the amount of money that you made. All right, so which one determines the other? Which one depends on the other? Does the number of hot chocolates you sell depend on how much money you made? No, not really, right? The easiest explanation here is that the amount of money you make depends on the number of hot chocolates that you sell. So for dependent, you could write amount of money made, or you could just write amount made, or whatever. If you're trying to take a shortcut, that's fine. So amount of money made depends on, I'm just going to say number sold. If you said number of hot chocolates sold, even better. You got a better answer than I do. Okay, so that's a bit of a recap from yesterday. I'm moving my hands a lot for some reason. You can't see that. The other part, oh, the dryer's done. The other part of yesterday was to create scatter plots. Now, because I'm sure that's super annoying and some people probably don't really have a great way of doing it, what I've done today, scatter plots were supposed to be a big part of it. Making them, that is, but instead I've made the scatter plots for you, and then you are going to take the scatter plots and do some analysis of them. Now the handouts are available in the classroom, in the classwork area, and they will be every day, okay? So let's go ahead and take a look at what we're doing today. I should also mention that at 3:00 p.m. on Monday, the solutions to lesson 1 went up, and that's the way it'll go. So the solutions to today's stuff will go up at 3 p.m. today, etc., and I'll try to keep that going moving forward. Okay, so today we're going to do 3 things. The first thing is draw a line of best fit. I think you'll find this fairly simple. My concern is that people will try to connect the dots. I'm really going to try to hammer home that connecting the dots is not what you're supposed to do. The next part is to identify trends in relationships. Sounds more complicated than it is. And lastly, we're going to use our lines of best fit to estimate values. Interpolation or extrapolation. Again, sounds way harder than it is. This stuff is not difficult. So here we go. This is in your handouts again, so I should be working with the handouts as of now. Here's a scatter plot. We've got age versus earnings. The numbers obviously aren't necessarily realistic to what people should expect to make. They're just numbers I put in just to create a trend. So the first thing you're going to do is draw a line of best fit. Now, you should use a ruler for this. If you're doing it on a computer, that might be difficult. I have my trusty line tool. And so that's what I am going to use. So a line of best fit is not like this. It doesn't just go from the first point to the last point, because if you look at that, that doesn't fit, right? Most of the data isn't anywhere near the line. So instead, we draw our line and we try to get it to go as close to most of the data as we can. And then what we want to do is we want to make sure that that line extends all the way back to the beginning. And really what we're going for here is we want about the same number of points above the line as there are below the line. And you can tinker with this a little bit depending on how you're doing it. And you're probably asking the question, well, what about these points over here? Well, those points are called outliers. And you may have heard this term before. Sometimes the term outliers is used to refer to like geniuses, people like Albert Einstein and that don't really kind of fit with the way other people are. They're a little bit different than most people. There's lots of examples of that. In data though, it's just outliers. They don't fit with the rest of the data. So what I did when I drew my line, I ignored them. Because if I tried to make that work, the line would be way down here, and all of a sudden you can see it doesn't really fit with almost anything anymore. So I go with what fits with the majority of the data points, and then we would consider these separately. We'd have a conversation about, well, what's up with those points? They don't seem to fit. So this is my line of best fit. I think it does a pretty good job. Okay, so that's step one of today. So in our three-part of today, line of best fit, we did it. Number two, we're going to identify trends. So I'm going to go to side by side here, like I often do in class. Draw a line of best fit. Yes. Does the data support the hypothesis? So the hypothesis is the older you are, the more money you earn. Now we're going to ignore the outliers. We're going to ignore all the points. And the only thing we're going to look at is the line. Now if you're looking for the labels, because of the program I'm using, they're actually going to be here, age, and here, salary. And so the question is, as you get older, do you make more money? And this data would say yes, because the line goes up. And as you get older, the amount of money you make goes up, except for these two people, which we will talk about shortly. So I'm going to say here, yes, the line goes up and to the right. Okay, so far so good. Explain why the data for ages over 65, that's these two people, these outliers, do not correspond. So I would love for you to think about this yourself. This is always a fun part of this lesson in class when people talk about why those older people were making less than so many others. Oh, the line doesn't ho up, it goes up to the right. So I encourage you to pause the video and try to think of a reason why those 2 points are the way that they are. So please, if you can, pause now and think about it. All right, so a great answer that came up in my first semester class was they said, well, sometimes those older people aren't working anymore, they're retired. Sometimes they're collecting pensions. And if you don't know much about pensions, it's basically a fraction of what you were making before. So those people could have had very high paying jobs, but now they're retired and they're getting pensions. Okay, so I'm going to say they may be retired or collecting pensions. Okay, now for the big part. So, in terms of what we're supposed to do today, we have drawn a line of best fit. We identified trends. As age goes up, income goes up. That's a trend. That's a relationship. Again, it's not hard stuff today. And the last part is this extrapolation, interpolation thing. So, we're going to fill in this table, and we're going to go one column at a time. So first we will do this column here. So age 20. Now, what we're supposed to do is we're supposed to use the line of best fit, okay, not the data points, not the table, just the line to answer these questions. So if you're 20 years old, what salary should you expect? So let's go here. So that's 25, that's 30, so this is 20. So what you're going to want to do, again, if possible, you're going to want to use a ruler here, and I'll do it with this little guy here. Oh, sorry, I'm going to go up from 20 up to our line, and I'm going to go to a single page, and I'm going to make it nice and big. Let's go down. So you go from 20 Okay, from 20 up to the line, and then once you get to the line, you're going to go over to the side here. Okay, and I'm going to have to fix this a little bit because I'm doing it on a computer. So we go up to 20. I'm going to change these to really thin lines, make them dotted as well, make them green so they stand out, or yellow. No, yellow would not stand out, and I'll have to make them a little bit thicker. Okay, so there we go. All right, so 20 years old, I go up to the line and over. That looks like about 20,000. So in here, I would write, I'm going to write this, check this out. I'm going to say about 20,000. So that little squiggly line, that means around approximately 20,000. And now for the final part of the lesson is that interpolation or extrapolation. So this is sort of like a new point on our line. Now the question is, if we put a circle around the data, was that point inside or outside the circle? I think it's quite clearly outside the circle. So it's outside, it's extra data, and so it's extrapolation. And don't worry, there's 3 more to go here. 3 more to go. Extrapolation. Okay. Now, salary 50,000. What's the age? And is it interpolation or extrapolation? So 50,000 is way up here. So I draw a line straight across. And once I hit my graph line, I'm going to have to zoom it a little bit differently here. Once I hit the graph line, I go straight down to here. Okay, and then I'm going to change it to dotted lines. Makes it a little easier to look at. Makes my graph a little less cluttered. And let's make it, I don't know, purple. Okay, so 50,000. I come down here. I'm going to zoom in. So this is 65, 70. That's 75. That looks like about 73. Okay? So I'm going to say here that that is about 73 years old. Now again, you might say, well, that doesn't make sense because older people, are making less. But based on our line, that's where we would expect them to be. So if those people continued to work and didn't retire, this data suggests that's where they would be. And again, this isn't perfect, right? None of this stuff is perfect. Okay, so that's the answer to that one. Now, interpolation or extrapolation. If you put a circle around the data, is this inside or outside? And it's definitely outside again. So once again, it is extrapolation. Extrapolation. Okay, next one, age of 55. Age of 55. So for 55, we go up to the line, and we go over to here. Now, you will notice there is a data point for 55. Don't fast forward this part. So there's a data point for 55. So you're going to be tempted to say, oh, 41,000. But remember, it's not about the points anymore. It's about the line, the general relationship. So based on the line, it looks like our answer is about 40,000. So about 40,000. So about $40,000. And then we go back and we're going to determine whether that's interpolation or extrapolation. So here's our new line. If we put a circle around the data, is this inside or outside that circle? It's inside, so that is interpolation. That is interpolation. Interpolation. Last one, salary of 35,000. So we come over here, I draw my line, I get to the graph, and then I go down to the x-axis or the independent variable, and there I am. That's 45, I don't know, 46? If you said 45, that's good too. I'm going to say about, I think I said 46 years of age. And finally, interpolation or extrapolation. We were here, the data circle is here, we're inside it, so it is, again, interpolation. Okay, now, what I was going to work through the whole next one as well, but we're already at 15 minutes, and I don't want to take up too much of your time. So what I'm going to do now is I'm going to pause it, and I'm going to answer all this stuff. But the first thing, before I do that, I will draw the line of best fit for you for the second one. So that looks about okay. So we've got 1, 2 above, 1, 2. Oh, we got a lot more below. So maybe I'll kick it down a little bit. That looks pretty even to me. And yeah, these points are pretty far. It's not perfect. None of this is going to be perfect, and that's okay. So there's our line of best fit, the best that I can do. Okay, so the follow-up questions are here. And before I do that, in terms of your homework, if you're asked for the independent variable, that's this one. So the length of the radius. The dependent variable is up here. Okay, and now what I'm going to do is I'm going to pause it, and I'm going to fill in this table here after I answer this question. Describe the relationship. As the length of the radius increases, the length of the humerus, so let's see, as the length of the radius increases, let's follow the line. Well, the line goes up. So as the radius increases, the humerus increases. And that is our trend. I drew the line of best fit. I'm going to pause it now, and I'm going to do all the work and fill in this table here for you. Okay, so I've done the first two. You can see my lines. You can see my answers. I wanted to unpause and show you the next one. So length of radius, 20. So if I go back here, the length of the radius, this is 22, 21. So 20 is right here. So I go up, and it's right about there. Right about... Sorry, I clicked on something. So I go from 20, it's all pretty much 22. So I'm going to say about 22 centimeters. You might have noticed these capital I's. That just means interpolation. I find students don't like writing the big long word, and I'm fine with that. All right, now let's go back. Is that interpolation or extrapolation? So we're over here, remember? Here's our original data. Are we inside or outside that? We are outside. It's extrapolation. And the last one, humerus, 30 centimeters. Way up here, I go over. I put that a little bit low. Again, it's because I'm doing it on a computer. I got to extend it so it gets to the line. So 30. Go here. I drop down. Okay, so let's see here. So that's 24, 25. I don't know, 25.3, 25.4, something like that. So about 25.4 or 3. It doesn't matter. Either one of those is great. Is it interpolation or extrapolation? Well, here's the data. It's a little bit outside, but still outside of it, so it is extrapolation. So there's your answers to that. The handouts have 2 of these practice questions for you. One's about grades. Again, I did the scatter plot for you. I'm trying to make this easy. And the other one is about height and weight, data that I believe we used yesterday already. Okay, so here's everything. That's the homework. That's it. I'm trying to keep this as light as I can while still getting everything across that I need to. I know everyone's situations are different. Please don't hesitate to get in touch if you need help with any of this. If you have some questions, whatever, let me know how I can help you best. All right, folks, good luck, and I'll talk to you again soon.